introduction for our presentation, which are about chromatography. Chromatography is a physical method used to separate the component of a mixture based on their movement through a stationary phase while being carried by a mobile phase. The technique works on the principle that different substances interact differently with the two phases, causing them to travel at different speeds. Common type of basic chromatography include paper chromatography and also thin layer chromatography, which are known as TLC, which are often used to separate color pigments, dyes, or chemical compounds. The stationary phase, like paper or silica, remain phase, while the mobile phase, which are usually a liquid solvent, move through it carrying the mixture component. A key concept in chromatography is the retention factor, which is RF, which help compare how far substances travel relative to the solvent. Chromatography is widely used in fields such as biology, chemistry, food science, and forensic for identifying unknown substances, testing purity, and analyzing complex mixture.
Now let's take a look at principles of chromatography. So most samples are actually a mix of different substances, and to figure out what's inside, we need to separate them first. Each substance in a mix behave differently. Some stick more to the stationary part, which is the particles doesn't move, while others follow the moving part, which is the mobile phase. Because of these differences, the substances spread out and separate. This helps us to see and identify what's in the mixture. How does the separation work? Substances that stick more with the stationary phase will move slowly with flow of mobile phase, while the substances that stick less with the stationary phase, it tends to move faster with the mobile phase. The differences cause each substance to separate into bands, and the separated bands can be analyzed and identified. As example below, the first one is initial state. Sample is absorbed on the solid phase, which is the black and orange is the sample mixture, and the pink is the stationary phase. And the second, when the eluting solvent begins to flow through the solid phase, as the solvent moves, the components of the mixtures move at different rates, which the less polar components will travel faster, and the more polar components will travel slower.
So let's see to the chromatography terms, which is there are three parts of terms in chromatography. So the first is elution, and the second is LUN, and the third is LUA. So the first is elution, which is elution is the process in which solute are washed through a stationary phase by the movement of a mobile phase. So the second is LUN, which is LUN is the solvent used to carry the components of a mixture through a stationary phase. So the last is LUA, which is about the mobile phase that exists the columns. So next, let's see to the stationary phase, which is stationary phase is the static part, and then the porous solid or coat with liquid stationary phase that fits in a place. So and then the stationary phase is to absorb the component that are being separated where the solvents and analyte or components travels through it. So other than that, we have mobile phase, which is the mobile phase is the moving part, and a phase that move over or through the stationary phase, carrying with it the analyte mixture. So the mobile phase may be a gas or a liquid or a supercritical fluid. So let's see to the retention times. Retention times is the time required for the sample to travel from the injection port through the columns to the detector. So in table, we can see that retention time is over the table in axis. So SI unit for retention time is minutes, which is we can see in the table we have 5 minutes, 10 minutes, 15 minutes, and so on. So let's see in the chromatography we have retention factor, which is it's about the calculation in this chapter. So what is retention factor? Retention factor is the ratio of the distance traveled by the substance to the distance traveled by the solvent. So let's see in the picture we have A and B, which is A is the distance traveled by the component and B is the distance traveled by the solvent. So if retention factor equal to the zero, solute remains in the stationary phase, which is call it immobile. So if retention factor is equal to 1, solute has no affinity towards stationary phase, which is travel with the solvent front. So the formula is retention factor equal to the distance traveled by the component A over to the distance traveled by the solvent B.
There are two types of separation for chromatography. The first one is partition chromatography. This separation is based on solubility differences between two phases. It occurs in systems with liquid stationary and also liquid mobile phases. The example is paper chromatography. Water in the paper is the stationary phase. Meanwhile, the solvent like ethanol is the mobile phase. Substances that is more soluble in the mobile phase will move further. And then the second one is adsorption chromatography. This second separation is based on adhesion to the surface of the stationary phases. It is common in thin layer chromatography, which is known as TLC. For example, the stationary phase is silica or alumina coating. Polar compound will stick more and move slower. Meanwhile, the non-polar compound will move faster with the solvent.
So there are three techniques of chromatography. First, paper chromatography. The type is planar chromatography, and the stationary phase is paper, usually cellulose. The mobile phase is liquid solvent. For example, water and alcohol. The application is separation of pigments, amino acids, and yeast. And the key principle is capillary action move the solvent up the paper, carrying the components at different rates. Second, thin layer chromatography, and the type is also planar chromatography. The stationary phase is thin layer of silica gel or alumina on a glass or plastic plate. The mobile phase is solvent or mixture of solvents. Application, drug identification, purity testing, and plant X-rays. And the key principle is components travel at different rates based on polarity and adsorption to the stationary phase. And the last one is column chromatography. And the third is also column chromatography. The stationary phase is packed column, which is silica and alumina. The mobile phase is liquid solvent, application, purification of compounds, and separation of natural products. And the last one is P principle, which is components elute at different times based on interaction with the stationary phase.
Chromatography is widely used in real life, especially in pharmaceuticals. It helps determine the amount of a chemical in a new drug sample, ensuring proper dosage and safety. In manufacturing plants, chromatography is used to check the purity of chemical needed to make a new product, ensuring high quality and safety in the final output. Next, environmental agencies use chromatography to determine the level of pollution in the water supply, helping to ensure it is safe for human and environmental health. Chromatography is used to detect blood or alcohol levels in a patient's bloodstream, aiding in diagnosis and treatment decisions.
So, in conclusion, chromatography is a method used separate and identify different substances in a mixture. So, it works by moving a liquid or gas mobile phase through a solid or liquid surface, which is in a stationary phase, and different substances move at different speed, allowing them to be separated. The retention factor value helps identify each substance by measuring how far it travels. So this technique is useful in science, medicine, and industry for testing, detecting, and purifying chemicals.